untuk soalan pertama, obtain the area in meter square. So kita tahu yang A equal to pi r square. So kita differentiate dia, which is dA over dr equal to d over dr dalam kurungan pi r square. Okay, so kita differentiate, 2 bawa kat depan pi, r2, r kuasa 2 tolak 1, dan kita akan dapat 2 pi r. Itu untuk soalan pertama. Yang kedua, dia suruh kita cari increasing constant rate yang diberi 2 meter per second. So itu kita punya dr over dt. Jadi sekarang kita pakai chain rule untuk solve this question, which is dA over dt equal to dA over dr akan darab dengan dr over dt. Sekarang ni, based on question 1 tadi, kita ada nilai iaitu dA over dr sama dengan 2 pi r. Okay, kalau dr over dt pula sama dengan 2 meters per second. So dalam question ni dia bagi kita r equal to 40 meter per second. Okay, so kita just masukkan nilai je daripada chain rule tadi, dA over dt equal to 2 pi r darab dengan 2 meter per second. So just solve, ganti nilai, and then kita akan dapat dA over dt equal to 160 pi meter per second. Itu saja. Itu salah satu.
So, we move to the next question, which is question number 2. The height of the cone which assumed as typical h, which is 16 cm, and the radius of the base cone, which is typical r, which is 4 cm, and the radius of the liquid of the cone we assume as r, and the height of liquid of the cone we assume as h. The angle of ABC and ARK is similar triangle. So, we divide RK over BC is equal to RA over BA. RK, which is 4 over R, and RA 16 over BA, which is H. Then we got R is equal to 4H over 16, and the final is we got R is equal to H over 4. Then we know the value of the cone, which is 1 over 3 times pi times r square times h. Then we substitute the equation, which is V is equal to 1 over 3 times pi times h over 4 square times h. Then we got V is equal to 1 over 3 times pi times h square over 16 times height. Then we got V is equal to 1 over 3 times pi h cubic over 16.
Then we move to the differentiate. dV over dt is equal to dH over dt in bracket 1 over 3 times pi h cubic over 16. dV over dt is equal to, in bracket, 1 over 3 times pi over 6 times dH over dt h cubic. So, dV over dt is equal to 1 over 3 times pi times 3h square. dV over dt equal to pi h square over 16 times dH over dt. dV over dt is equal to 2 negative 2 cm square per minute. 2 is equal to pi h square over dH over dt. 32 over pi h square equal to dH over dt, so h is equal to 8. dH over dt equal to 32 over pi in bracket 8 square. dH over dt equal to 32 over pi in bracket 64 equals 7 over 44 cm per minute. It also equal to 1 over 2 pi equal to negative 1 over 2 pi cm per minute. So the negative sign show the liquid level is decreasing.
So today I will explain about question 3. So the question is, the drop in voltage V when current is passing through a circuit is given by V bracket T equal to T power of 3 minus 9 T power of 2 plus 24T. From the equation that given, t power of 3 become 3t power of 2. 9t power of 2 become 18t. 24t become 24. So the first derivative is 3t power of 2 minus 18t plus 24. Zeta will continue this answer.
Next, we need to determine the critical points by setting the first derivative to 0 and solving for t. So from the equation 3t squared minus 18t plus 24 equals to 0, we simplify the quadratic equation by dividing all of them by 3, and we got t squared minus 60 plus 18 equals to 0. We then factorize the quadratic, and then we got bracket t minus 2 and bracket t minus 4 equals to 0. Thus, the critical points are t equals to 2 and t equals to 4. Now we need to evaluate Vt at the critical points and at the endpoints of the interval 0, 6. So we need to replace the value of t by t equals to 0, 2, 4 and 6 at the equation of t squared minus 60 plus 8 equals to 0. So we calculate all of them, and at t equals to 0, we got Vt equals to 0, and at t equals to 2, we got Vt equals to 20, and at t equals to 4, we got Vt equals to 60, and at t equals to 6, we got Vt equals to 36. And finally, we compare the values of Vt at these points to determine the absolute maximum value on the And finally, we compare the values of Vt at these points to determine the absolute maximum value on the interval 0, 6. So, as we can see, the results are V0 equals to 0, V2 equals to 20, V4 equals to 16, and V6 equals to 36. And from here we can see that the highest value is 36 at 6 seconds. Therefore, the absolute maximum value of the voltage drop Vt over the interval 0 and 6 is 36 millivolts at t equals to 6